Hey guys, this is the PEP8 virtual machine software that you can download from the internet. It is up on this site, computersystemsbook.com. The PEP8 virtual machine has, when you first open it up, it has two panels up. On the left-hand side, you have various types of source code. The only type of source code we're going to be dealing with here is the object code. Object code is another word for machine code. And then on the right, you have a view of the CPU and the input that you would be providing and the output. We're going to see that we can type the input that a user would expect to type ahead of time, and it'll go into the program. So if we come over here, we aren't writing source code. We'll talk about that later. That's higher level. We're not writing assembler code. That's also a little bit higher level than what we want to do. We're literally going to be writing machine code using the PEP8 instruction set. A little bit about the user interface real quick. At the top, you can make a new document, you can save. These buttons here to assemble will turn assembly into machine code. We're not doing that yet. This thing to run, it'll run the source code, but we're not dealing with the source code yet. We will be using some debugging, but in order to do that, we're going to need to go through this build menu, and we're going to need to say to run or debug the object code itself. Up here, we've got these text boxes. These do conversion for you. So if I type in the hexadecimal number 50, it shows it to me in decimal. It shows it to me in binary. Shows it to me in ASCII. And later, we're going to be reading about assembly. It shows me the corresponding assembly mnemonic. So this is character output, and there's different modes like direct or immediate, right? So 49 would be character input, and these bits, you can find them in your textbook explaining what the instructions are. Down here is where you would type in object code, and I'm going to turn in your textbook. There is a hand simulation that writes out the word hello world. And your book has the hex instructions, and I'm going to type them in right here. The first time I tried to do this, I got it wrong, and I'll tell you how I got it wrong. You type in the hex instruction 50, and then in the book it has 0048. And originally I thought I could go to the next line and type the next instruction, but you can't. What you need to do is for every 2 hex digits you can put a space. But they all have to be on the same line. So one big run-on. So 50, 48, 48 if I type it up here. I'm sorry, 48 is a hexadecimal number. If I type it in up here, I see that it's the ASCII letter H. Right? So, and 50 is going to be the command that outputs something. So if I type in 50, it's a character output command. So that outputs the letter H, and 00, I want to write an E, so I put an E in there, and then I see that it's the hex 65. And I want to write an L, and it's the hex 6C. And what I'm doing is I'm writing 50 and then 00, and then the letter. So that's another 6C because it's HELLO. And then I want to write output an O. So O is a 6F. So this should be the word, this should produce the word hello. To end my program, I'm going to stop the program with a 0. And in the object code listing, to indicate the end of input, after the stop, so you write the stop 2 zeros, you put a ZZ. And this actually isn't part of the object code. This is just how this tool knows that the text is done. Over here in the CPU, you can see some of your registers. We don't use all of them in this chapter of the book. We use the accumulator, and here we'll have it in hex. And we use the sort of the instruction and the operand. Together, these things make the instruction register. Let's see. Oh, and there's the program counter. So there's other registers we might learn about later, but we're not using them now. There's also, if I go to view, there is, I can view the CPU memory. So initially it's all 0, but what'll happen is, and this is kind of an important thing that happens when you're writing programs, is after you run the program once, this isn't necessarily all zeros. So you might want to clear the memory before you run it again. Otherwise, it's easy to make a bug where you assume it's 0 and it's not. So let me kind of show you what happens now. So if I go to build and I say load, then it takes this object code, everything before the ZZ, and it puts it into memory starting at address 0. All right, so you can actually see the HELLO in there. If you mess up, then like for instance, if you hit a new line in here or something, what gets copied into memory is the wrong thing. So just verify 500048, 500048, and then immediately after that 500065, 50. So there's no extra weird bits in there. Let me show you what happens if you put a new line in your code because you're trying to make things look pretty, and then you try to load it. Well, it may or may not load properly. So last time I tried that, it actually didn't load properly. And let's run this thing. So if we build, you don't want to deal with the source. We're dealing with object code. I always, when I'm coding, debug first. So I'm going to hit the debug button. The reason that we're debugging is so that we can see step by step exactly what happens. So the output of this program is going to come out down here in the output window. If I click on, so if I run this, if I want to stop it, I hit this thing, and if I want to step through it one instruction at a time, I can do the single step operation. When I do single step, it's going to look at the program counter. It's going to load that instruction into the instruction register and run it. So we're going to single step, and it outputs the H. The next one is going to, and here we can see that that last instruction is sitting here in the instruction specifier. If I single step, it's going to do the instruction. It outputs 65 as an E, and then I'm looking down here at the output, and then single step the L, and the next L, and the O. So you can kind of step through, and then finally it stops. So that ends the program. You can step through and see what's going on as you are pulling these instructions out of memory. A little bit. So you've also got a terminal for. You can either have your input pre-entered, or you can kind of type it in as you run it. So what I'm going to do now is I'm going to run a little bit of code that that was in the book that reads in 2 letters and prints them out in reverse. So the operand that reads in, let me come up here, is 49. 49. That reads in a character. So it's going to read a character that I type, and it's going to store it. It's not going to. It's going to store it somewhere in memory. So in order to do that, I say 49, and then I have to provide the memory address. And I can pick anywhere I want to put it. I don't like where your book puts it because I'm going to try to get it to line up nicely with one of these rows. So I'm going to start at 20 hex. So I'm going to put that first character that I read at this position that I just highlighted, at address 20. And okay, this happens occasionally. The program crashed. Get used to it. This is a part of computer programming, unfortunately, because often you find yourself using, there we go, using tools that are not, that are a little bit closer to the bleeding edge, or that, like this one, are more, have a very small audience. And one of the most challenging things about software is testing your code in every possible environment that it could run, portable code. The people that wrote this code didn't know exactly how I would be running it. I'm currently running it off of my memory stick, and for all I know, they may not have anticipated something that happened when you run it off of a memory stick. So over here we got the memory. I'm going to write a new program, and the first thing that I'm going to do is I'm going to input a letter, and I'm going to store it at address 20, and then I'm going to input another letter. So remember 49, it does the character input, and then I give it the address, and I'm going to do the next, each character is 1 byte. So it reads in an ASCII character code. They're 1 byte long. So I'm going to put it at the next spot. And you know what? I'll just read in. Your book only did 2. I'll do 3. So, or actually 4. So this should be 4 characters. And then once you've read them in, you can print them out. So we already did printing out. That was the 51. And what the book does is it prints them out in reverse. So the most recent thing that I read, okay, here's another thing about programming is, you think the connection between your mind and your fingers is great, but you're used to having a spell checker, etc. And in English, a spelling error doesn't matter. You type in a machine code instruction wrong and your program just won't work at all. I'll introduce an error back in a second. But yeah, I just made a typo that I fixed. So 51, I'm going to output the last thing I read, which was at 23, and then I'm going to just count down. And I'm going to output the symbol at 22, and I'm going to output the symbol at 21, and I'm going to output the symbol at address 20. This is working back through the memory address, and again, even though I said 51, I typed 50. You're going to find yourself doing this a lot. So 51 is character output. 50 is also character output, but it expects the character to come from a different place. So the all right, and you can kind of figure that out by looking at the way the instructions are described in the book. So when I'm done with this program, I do the stop code to finish it, and then ZZ. And if I go here and go into memory and load it, verify that it's there in memory. Looks correct. And under the input for batch IO, I'm going to type in, what did I give it? 4 letters. John. That's my name. I'll go ahead and make that J uppercase. There we go. And let's run this thing. So if I go to build, I've already loaded it. And so now what I'm going to do is I'm going to start debugging the object code again. So this is a character which is supposed to load from the input and store it at address 20, which is down here. So it's going to read a character, it's going to interpret that as kind of a hex, and it's going to write it out. So if I do a single step, it wrote the hex for J. So if I look up here at J, oh, that thing doesn't work apparently when you're running. Apparently the hex for J is 4A, and it shows me here in ASCII that I just added J in. If I do the next step, it's going to read the next character, O, from the input and stores it in the next memory location. It stores it in the memory location I told it to, which was address 21. And then if I do the next single step, it's going to store, here I can see, it's going to store in address 22, the next thing I read, which is going to be an H and an N. So now I've read JOHN. I can see here that my next instruction is at 51. 51 is character output. When I do that single step, it's going to print the contents of address 23, which is this one, N out. So N, and it's moving it's going to do 22, which is H, 21, which is O, and 20, which is J. So it's printed out the name backwards. The next one is going to do that 0, which stops the execution. So John becomes Naj. You kind of see how that process works. Your book has a bunch of other machine code instructions. You could play around and try to do something more complicated. But this is basically, at some level, ultimately the way a processor works. It takes the machine code, loads from memory into these registers. These registers are actually implemented using digital logic inside your CPU, and they're extremely fast to access. So you pull something into the register usually and then do something with it there. That wraps this up. Let's see you next time.